So let me download the syllabus. Huh? Have you checked the syllabus? Everyone? Guys, the people are available?
Yes, sir.
Yeah, okay. Okay, I will present the screen and start. So just a recap of everything what we seen which is related to our syllabus. Can you able to see the screen?
Yes, sir.
Yeah. I will project the syllabus also. So you're saying the syllabus, huh? Can you able to see the syllabus?
Yes, sir.
Yeah. So in the fundamentals of DC circuit, we talked about the introduction and the network element. So network elements means the various elements which we are using to design the circuit that we seen. For an example, the voltage source. What is the voltage source? What is the current and what is the current source? And what is the definition of the voltage, current, and the resistor, capacitor, inductor? What is the power? So these are the elements comes under the network element. And Ohm's law, we already seen some basics of the Ohm's law, and we are going to apply that to analyze the circuit and the Kirchhoff law. So this, so this is what we've seen up to last classes. Okay, just a recap. I will go. So the current basics you already know. What is the current of flow of electrons? What is the electrons? It is nothing but the negative charge particles. These kind of things we already studied. And elements that are classified. Can you able to see the screen, guys?
Yes,
That
sir.
1.3 classification of circuit
Yes,
elements.
sir.
So
Yes,
there
sir.
are yeah. We are categorized
Sir,
the
sir, when
elements.
will we get the PDF, sir, of this syllabus? Sorry, of this chapter, sir? To
Today I will
study.
post it. I will post it.
Okay, sir. Okay, sir.
Okay. So active elements and passive elements we are just categorizing. So what is an active elements means which will be able to consume the energy as well as providing, supplying the energy. These kind of elements comes under the active elements, and the passive elements representing it will dissipate. I mean convert the energy into another form. It will dissipate the energy in form of heat. Okay. So you just take the active elements. We are taking a example as the voltage source, current source, generators, and transistors. Transistor, you know, right? You know what is a transistor, right?
Yes, sir. Yes, sir.
Yeah. So transistor is nothing but a semiconductor device which we will use for amplifiers and circuit switches likewise. So even microprocessor is fabricated using the transistors only. So these kind of elements comes under active, and the passive is normally like a resistor, inductor, and capacitor. These kind of things comes under your passive element. Okay. And the electric current already we've seen, they're giving some formulas like I is equal to Q by T, and we seen that change in charge with respect to the time dQ by dt. That relation we've seen here. And EMF, no need. The voltage, we know what is the voltage and electrical potential. Both are similar. We can able to call it as a voltage. It's nothing but the potential difference. Okay. So it is denoted by the unit V. Listen, carefully listen, guys. While solving the problem, after you got the result, you have to put the unit, particular unit. If you are calculating the resistor, you have to put the ohm symbol. Otherwise, if you're calculating the capacitor, it will be a farad. If it is a inductor you're calculating, you have to put the Henry. So don't forget to put the unit, otherwise you will lose the marks. Okay? And similarly, and comes to the power, it is nothing but product of voltage and then current. Otherwise, the work done, how much work is done per unit time, how much work is used to push the 1 coulomb of charge. Yesterday we seen in that in that last class we seen what is the definition of power. Otherwise, you can give a simple definition like a power is rate of doing work. So these are the simple definition which used to give for different parameters. And and energy, in your home you having the energy meter. What is the use of energy meter? What is the use of energy meter?
You see the amount of energy applied, sir, or like what?
With respect to the time. So based upon the time, how much energy we consumed. That's why we're using the energy meter in order to calculate the traffic, how much electricity you consumed based upon the time. Okay. So charge, that the electrons, the charge, that 1 coulomb values they given. This you already you've seen in physics 1.62 into 10 to the minus 90. Okay, so these are the basic parameters, the resistance and inductance and capacitance. And you need note it down the units ohm and how the symbol is Henry. Don't forget. And conductance. So conductance we didn't see. It is nothing but the reciprocity of your resistor. So 1 by R. Conductance is different as G. Wait a second. Yeah. So conductance denoted by G, and it is nothing but the reciprocal of your resistance. Guys, can you hear me? I think I got
Yes, sir.
Yes, sir.
which is the last one?
You are in conductance.
Conductance. Okay. So conductance denoted by G. So it is nothing but the
Sir,
reciprocal.
slide is not visible. Slide is not visible, sir. Slide is not visible.
Okay. Okay. Now it is visible.
Yes, sir.
Yes, sir. Visible, sir.
Yes, sir. Visual, sir.
So conductance, it is quite opposite to your resistance. It is denoted by 1 by R, and the unit is also inverse. It is inverted. Usually for resistance we used to call a ohm, and here it is mho, M, and the symbol also it is inverted ohm. So you have to draw like this. Next is come to the resistivity. I ask you a question. Uh, the resistance is based upon the conductor which you are using. For example, take a wire. If the thickness of your wire is increased, then what is your resistance? It will be increase or decrease?
Resistance will decrease, sir.
Resistance will decrease surely. And if I increase the length, what will be your resistance? It will be more or higher? It will be increase or
I
decrease
think it
if
will
I
be
increase the
same,
length?
sir. It will be same.
If length is increased, the resistance will get
Breadth,
increased.
sir.
Is it, sir?
If length is increased, yeah. See, if
Breadth.
you calculating, if you calculating, if you're calculating a small copper wire, it may have a resistance of 1 ohm in the sense. If you take, for example, first I'm calculating 1 meter wire, it is having a resistance of 1 ohm. If I am taking a 5 meter wire, it may have 5 ohm. Okay, for 1 meter, how much resistance it is there? The same will be applicable for another 1 meter. If you connected in series, then you know that resistance will get added, right? It will be sum of your each and individual wire. So one wire consists of 1 ohm resistance.
One.
Then if you connected multiple wires, so it will be increased. So the resistance is depend upon the length, and the area is inversely proportional. Area means nothing but the cross sectional area. Otherwise, I told you like thickness. So if thickness increased, then the resistance get decreased. It representing that in a thin wire we may have the conductive element will be much less. If we increase the area, then the conductivity will become higher, so resistance will get decreased. But what about the length? Why length increase, the resistance increase means it has to travel for long distance. That is the reason. So area representing that we may generate more number of conductive elements, but if length is increased means that conductive elements has to travel from one place to another place. So this is nothing but the electrons. Electrons has to travel, right? So if you keep on increasing the length, the resistance will get increased. So R is directly proportional to your length and
Length.
inversely proportional to your area. And in this, we have a rho. So that is nothing but the resistivity. That is, it is a constant value for your metal. Okay, so that's why they represent R can is directly proportional to your rho L divided by A. Okay. The next is a network and circuit. We seen in last class about the basic circuit, right? How to connect, and in series means what will happen, in parallel means what will be happen. Now come to the Ohm's law. We seen what the Ohm's law V is right, and if you're having the resistance, it is nothing but V is equal to I into R. And if you want, you can change the equation to calculate whether the resistance or a voltage or a current. You can change the Ohm's law. And there will be limitations for Ohm's law. It is not applicable for all the circuits. It will be applicable for particular circuits only. For an example, Ohm's law is applied for the circuit which is having the resistor, capacitor, an inductor, and voltage source, current source. But Ohm's law cannot be applied if you are using a transistor or a semiconductor device. Generally, I'm talking semiconductor device if you are using in a circuit. Ohm's law cannot be applicable. That's why there is a limitation in Ohm's law. So here they given some points like Ohm's law does not apply to all non-metallic conductor. So metallic conductor, non-metallic conductor. So we are applying for only the metallic conductor when Ohm's law cannot able to apply for non-metallic conductor. And second point, mostly it is not apply for a non-linear device like a Zener diode vacuum tube. So these are comes under the semiconductors. Okay, vacuum tubes and transistors. You can add a transistor and IC. So these are the things we cannot able to apply for Ohm's law. And next one is temperature change. If temperatures keep on changing, the Ohm's law cannot able to apply. Why? Because if the temperature change, the resistance will get changed. So due to that, the voltage current parameter will get changed. Okay. So these are some basic problems. Guys, now onwards, try to keep up in notes, and you can work out some small problems. You can draw the circuits. So
So
everyone
anyhow, you
take a
will be
note.
sending the. Anyhow, you will be sending PDF, no, sir. Notice
Yes,
mandatory.
yes, yes, yes. I'm sending the PDF, but practice is important one. While looking the
Okay.
circuit, you can remember on the time. While writing the examination, you may stuck. So on the time you might not get anything. So if you practice once in the note, then it will be easier for you. Better take a paper right now, and later you can attach it any note. Take a paper and try to work out. I will give you a simple problem. We will solve the problem. And yesterday, I mean, last class we seen the series and parallel combination on the summation of your resistance if it is in series. I told you, right? I taught already, right? Guys, in last class?
We saw series and
Yes,
parallel, sir, but the summation I don't know, sir.
Yeah.
I'm not sure.
Okay. Yeah, we will do. So resistance in series, it's yeah, the same. Here we are using the two resistance, and this is a voltage source. So this is the one complete site. I mean complete circuit. It is completed, and it is having one loop. Okay. So due to this, the current which is going, the sense the electron will go from in this direction, so that current is in this direction. Okay. How much electron is going from the negative because of attraction with the positive voltage which is available here, that will be end up in this. So the current movement will be in quite opposite direction. So in this only the one current will flow I. How many element, how many components you are connecting, it doesn't matter. What is the current can able to pass, that will be passed through complete circuit. For example, here if I'm using 1k and here V is equal to 5, and here also I'm using a 1k. Okay, can anyone tell what will be the current using the Ohm's law?
E is equal
sir.
to
5.
R.
by
I
R
will be
The 5 volts, sir.
I is equal to V by R. What is V?
is equal to 5.
5.
V is equal to 5.
5 by,
What
sir.
is R?
I is
What
equal
is
to
R?
5, sir.
1. 1,
I
1.
sir.
is equal to 5
R,
volts.
what is R is equal to 1. Here we having two resistors.
Yes, sir. R will be 1, sir.
So this is addition. Oh, wait a second. So you
Subtraction,
have to
sir.
write 2k. Just find out what is I. Find
I
out
will
what
I
is
be
I.
is
I
equal
will
to
be moved.
0.5, sir.
2k ma. 2k means 2 kilo ohm. Just find out
Oh,
and tell me answer. You check 1 minute. 1 minute time.
yes, sir.
So what is the answer?
0.0025 approximately.
0
Zero,
0.025.
0 to 5.
25, sir.
0.0025. Okay, 25. After that,
What? What?
what I am calculating
Current, sir.
Current.
What, sir?
current. So what is the
Ampere.
unit? Ampere.
Ampere.
What is for
Ampere.
power?
Ampere. Yes, sir.
Otherwise, I can tell 2.5 milliamps. Okay,
Yes, sir.
2.5 milliamps. Milliamps. Okay. Mute. I think one guy is using the loudspeaker. I'm getting echo. Shivam, mute your mic.
Yes, sir.
I'm getting echo sound somewhere.
No, sir. I
Okay.
am in silent zone, sir.
Okay. So 2 point milliamps. Now the thing is 2 point milliamps current will start to flow entire circuit. Okay. If I'm not using this second resistor R2, on the time 5 milliamps of current will flow to the entire circuit. This is the concept. How many resistor you use, based upon that it will reduce the flow of current. But what is the amount of current you calculated, that will be flow in entire circuit. That is a concept. Okay, so current is common in series circuit and voltage is common in parallel circuit, that we seen in last class, right?
Yeah, that we saw.
Yeah. Now here, I will remove everything. Okay, so I told you, like, if you connected a multiple string, a multiple resistor or multiple conductor together, the resistor will get added. Similarly here, if you want to calculate, means you have to recombine this resistor together. Otherwise, I can tell I want to find the entire circuit resistance to put as R equivalent. So R equivalent representing the total resistance available in a circuit. So that simply I can apply I is equal to what is the total voltage, how much you are giving, and what is the resistance,
5.
how much I calculated. Likewise, I can able to easily calculate. So what I want to do, I want to reduce the number of resistors. If the resistors are connected in series, you have to add it together. So that is nothing but your total resistance, otherwise the equivalent resistance. If you're having 2K here, 2K here, and the equivalent resistance is nothing but the 4K,
Okay.
it will be simply added together. And if it is 3K, here it is 3K, okay, and where you may get maximum voltage drop. Now voltage drop will be greater in 2K or voltage drop will be greater in 3K.
3K, sir.
3K. Yeah, if it is an open circuit, means more resistance means the voltage will be get more. If less resistance, voltage is nothing but very less. Okay. In this parameter, what I'm giving 5 volts, so it will be divided among 2K and 3K. So you can able to calculate easily using the voltage division rule. Like yesterday, last class I told. Suppose if you want to calculate V1, okay, what is the total voltage? It is nothing but
5.
5
5 by
multiply by. So you want to calculate the voltage across the resistance R1. So I'm writing R1,
Okay.
and I want to make a ratio between R1 and R2. So I'm adding what is the total R1 plus R2. So you can able to calculate what is your V1. Can anyone calculate?
yes,
So
sir.
if you're having the note, you can draw the circuit and you can calculate. So it will be useful for you.
The
Can
answer
you
is
calculate
2, sir.
to what you're getting? Okay. Now the simple concept. If you're getting 2 here, what you will get in this resistor? V2. It's simple logic.
3.
They left out 3.
3,
Yeah,
sir.
out of total 5, 2 voltage
Yes,
drop
sir.
occurring
2
here
is
means surely
yeah, the left
you
out
may
will be
get
there.
3 here. So yeah, so
Yes, sir.
entire voltage will be 5 volt. That is the concept. So here will be the solution. And next, come to the parallel combination. This is quite different. Okay, here the voltage will be common in this node. If you calculating, voltage will be common. For example, take here it is a 5 volt. The same 5 volt will applicable for the resistor R1 as well as resistor R2, because R1 one node is connected to A, similarly R2 one node is connected to A, and R1 and R2 another terminal is connected to node B. So for a 5 volt is available at R1 as well as R2 both. It is common. So that is a concept. Voltage, if you connected so many elements in parallel, means the voltage will be equal to each and every element. Now what about the current? Current will get divided. Why? Because here you're having the 2 branches. So this is like a water. Water is coming and you're having a 2 connections. So water will split into both
Both.
terminal. And just consider R is nothing but the control of your tap. How much resistance is there? I mean, if resistance is much more, in the sense pressure is much more, so the amount of current flow, the water will be less. If pressure is low, in the sense you are not using the tap, in the sense, so pressure is less means you are allowing the water. Similarly, if the resistance is less means you are allowing the current. Okay, so if R1 is, for example, 5K and R2 is 2K, whether the maximum current will flow through 5K or 2K?
It will flow to through 2K, sir.
2K, yeah, because 5K will resist the flow of current. Okay, so likewise we have to calculate, and this is the total current I. I can mention as I. So it will be splitted as I1 and I2. So the equation I can write I is equal to I1 plus I2.
I2.
I told you one
So we have to
concept
calculate it
that
like 2 individual times, and we have to add the 2 values,
yeah, yeah,
so that
yeah,
to get total
yeah,
resistance.
yeah. So the what current is flowing through R1 I1, that will become in this path, and similarly I2 will come in this path. This will be added together. Again, at the end of the circuit, you may get the same current as I. So in a circuit, what is the current is flowing? That will be end up at negative terminal. Okay, and shall we calculate what is your here you can calculate for example I is equal to I1 plus I2 already I did okay. What is the voltage across R1? I can write is equal to
I1 is equal to
okay. I want to calculate I1. I1 is equal to
V by R, sir.
so V is total, it is applicable, right? So I'm
Yes,
writing V directly.
5
In
by
previous case, we
R1 will
denoted
be
V1, V2.
5.
Remember, in previous case, we used to write the element like V1, V2, but current is total. But here, voltage is total, but current is treated as I1 and I2. There is a difference. Okay. So V by what is the R1?
Sir,
R1 is
5K.
5,000.
That is
5.
nothing but 1. So it is 5 by 5. 5K. 5K means we may get 1 milliamps.
It is 0.001, sir. 1 milliamp.
Yeah, 1 milliamps. 1 milliamp. Okay. And what about I2?
I2 is
2.5, sir.
0.0025, sir, ampere.
5 by
2.5
2.
milliamp.
So 2.5 amps.
So I1 plus I2 will be
Milliamps.
26, sir.
3.5
26 milliamps,
milliamps.
sir.
3.5 milliamps. 1 milliamps and 2.5 milliamps.
Yes,
Sir,
sir.
unga slide தெரியல, sir.
8.5 milliamps.
Is it not visible for everyone?
No, sir.
No, sir.
No, sir.
So,
No, sir.
Not visible, sir. I2 is equal to 5. அதான் sir.
Network.
now is it visible?
Now is it?
Yes, sir.
Yes, sir. Visible, sir.
Okay. 1
Voice
Sir,
கேட்கல, sir.
now your voice is not clear, sir.
Voice is not clear.
Here. From 1 milliamps. Is it audible right now, guys?
Now
Yes,
audible,
sir.
sir.
Okay.
Yes, sir.
1 milliamps addition to that 2.5 milliamps. What is your
3.5, sir. Yes.
current? 3.5 milliamps. So that is a current flowing. So this
Sir,
is
current
basic
flowing
circuit.
in
So
the
easily
resistance, sir.
end circuit. Yeah. R1 and R2. Otherwise, simple concept. You can reduce this R1 and R2 if it is parallel. I will draw here. This is a R1 and this is your R2. I want to calculate R equal value.
குரல்
Parallel.
கேட்கவில்லை.
The formula like yeah, not audible.
No, sir.
Yes, sir.
Okay, I will reconnect.
We can, sir. ஜாலியா பேசிட்டு இருக்கு. ஏய், என்னடா இது அதர்ஸ் இன்வைட்டட்ல ப்ரொடெக்டர் அமைட்டு இருக்காரு. வந்துட்டு போனாரா?
தெரியலடா.
சும்மா நல்ல வேலைடா மாட்டல. அப்படியே ஓபன் பண்ணி பார்க்கறேன், அதர்ஸ் இன்வைட்டட்ல ப்ரொடெக்டர் அமைட்டு இருக்காரு.
பாரு,
வந்து போயிருக்காரு.
போட்டோ அனுப்பிச்சு விட்டேன் பாரு.
என்ன போட்டோ? ஹாஸ்டல்
நீ
தான்.
கேட்டது.
சரி.
பேலன்ஸ் வந்து நாளைக்கு காலைல அனுப்புறேன்.
பரவாயில்ல.
ஏன்னா அவங்க இன்னைக்கு நைட்டு கிளம்புறாங்களா, நாளைக்கு காலைல வந்துடும்.
யார் நைட் கிளம்புறா?
சித்தப்பு. ஏய்
தல
உனக்கு புது
வாங்க
பேர்
தல.
நல்லா இருக்குடா. சித்தப்புடா உன் பேரு. சித்தப்பு நல்லா இருக்கு உன் பேரு.
ஏய் ராக்ஸ்டார் ராஜேஷ்ரா.
இல்ல மச்சான். சித்தப்பு தான் நல்லா இருக்குது. சொல்லுங்க சித்தப்பு.
என்னடா டேய்,
சொல்லுங்க ராக்ஸ்டார் ராஜேஷ். நல்லா இருக்குதா? செட் ஆகல. அப்புறம் சித்தப்பு என்ன மேட்ரு? சொல்லுங்க.
என்ன
உன்
மேட்ரா?
வாய்ஸுக்கு நீ பண்ற வேலைக்கு செட் ஆகுதுடா சித்தப்பு.
ஏய் அவன் ஏதோ கேட்கலாம் பாருடா.
அவன் என்ன கேட்க போறான்? பயங்கரமா நேத்து மேம் கிட்ட கேட்டான் பாரு, கம்ப்யூட்டர் மேம் கிட்ட. மேம் மொத்தம் பைத்தான்ல எத்தனை ஸ்டேட்மெண்ட் இருக்கு? ஒரே வார்த்தை தான்.
டேய் இல்லடா. டேய்
அந்த மேம் கதி கலைச்சு போயிட்டாங்க.
ஏன் சொல்லவா?
இத்தனை வருஷம் சர்வீஸ்ல இந்த மாதிரி ஒரு கேள்வி யாருமே கேட்டது இல்லையே.
டேய் இல்லடா.
சரி சரி
எங்களுக்கு
பேசு பேசு ஏதோ பேசணும்
இல்ல
பேசு.
இல்ல எங்களுக்கு எடுத்த மேம் ஒரே மேம் சொல்லிச்சு பைத்தான்ல 4 ஸ்டேட்மெண்ட் தான் இருக்குன்னாங்க.
அது நாளே
4 ஸ்டேட்மெண்ட் தான் இருக்குன்னாங்கடா.
Guys,
ஓ ஸ்டேட்
எஸ் சார் எஸ் சார் எஸ்
எஸ் சார்.
Yes, sir.
okay, enough of talking. Just come back to the class. Okay, is it visible? The screen is?
யா நவ் விசிபிள்.
Yes, sir.
Okay.
Yeah,
So
now
if
visible,
it is in parallel, if it is in parallel, we have to calculate what will be your equivalent resistor. So for that, there is a common formula like 1 by R equivalent. So this is quite different. Don't forget this. 1 by R1 plus 1 by R2 plus 1 by R, etc. So if you have multiple number of resistors connected in parallel, this is the formula. If it is only two resistors are connected in parallel, then you have only
1 by R2 வரைக்கும் தாங்க சார் தெரியுது. அதுக்கப்புறம் எழுதுறது தெரியல.
okay.
யா சார் 1 by R equivalent is equal to 1 by R1 plus 1 by R2 தெரியுது சார். அதுக்கப்புறம்
After that is not visible.
எஸ் சார்.
Yes sir. I think network issues.
சித்தப்பு
Yes. Now I am scribbling, that also not visible for you.
நோ சார் நதிங் விசிபிள்.
No, sir.
No.
யுவர் கர்சர் இஸ் ஸ்டாண்டிங் தேர் only சார், நாட் மூவிங் சார்.
Oh my God. Okay. For a two resistor, it is nothing but the same formula. 1 by R equivalent equal to 1 by R1 plus 1 by R2. If more number of resistor you have to add, means just simply do the addition with 1 by R3 and 1 plus 1 by R4, etc. So on. Okay. Now it is changing or not? Still it is.
அப்படியே இருக்கு சார்.
Yes, sir. Still it is.
There it is. Okay. Now you know the formula. Take the paper. I will tell the values of R1 and R2. Try to calculate it. The
Yeah,
equivalent
sir.
value.
ஓகே சார்.
Yeah.
This is the value.
Yeah,
This
so
is the formula
R-
to find R equivalent, sir.
R equivalent value. So here in last circuit, we found R1 and R2 as 5 kilo ohm and R2 is 2 kilo ohm. Now calculate what is the R equivalent value.
Sir, repeat again.
R1 is equal to 5K, R2 is equal to 2K. What is the R equivalent value?
R1 is equal to 5K.
R2 is equal to 2K.
Okay. R3 is equal to
Sir, 2.5, sir. 2.5 approximate milli.
5
milliampere.
Yes, sir. 2.5 only.
milliampere. You are calculating the resistance, not
அவன்
the
அப்படிதான்
current.
சார். அவனை கண்டுக்காதீங்க சார்.
Sir, 1 by R is equal to 1 by 7. 7 kilo.
1 by 7. Then what R equivalent?
Sir,
Sir, now your slide is also not visible. Voice also not clear.
Yes, sir. Go to a good night to us, sir.
Good night.
Oh my God.
கம்முன்னு இல்ல டவர் கீழே போய் உட்காந்துருங்க சார். நல்லா வருதான். விஸ்வா அது எப்படி விஸ்வா சிரிக்கும் போது கூட மைக் ஆன் பண்ணி சிரிக்கிறேன் நீ, அது மட்டும் எனக்கு சொல்லு விஸ்வா.
சம சொல்லு.
சிதப்பு
உன் சம சொல்லு, என்ன கண்டுபிடிக்கணும்
சொல்லணுமா? ஐயோ பாத்துறோம், உலகம் அழிஞ்சிட போகுது. இந்த மாதிரிலாம் ஆபத்தான முடிவெல்லாம் எடுக்காது. 1/R equivalent is equal to first R1 ஓட வேல்யூ 5k,
1/R1 + 1/R2.
R2 ஆமா R2 ஓட வேல்யூ வந்து 2k. இப்போ நான் R equivalent கண்டுபிடிப்பியான். அதை கேட்டு நாங்களாம் சூசைட் பண்ணி சாவோம்.
என்ன கண்டுபிடிக்கணும்?
R1 ஓட வேல்யூ சொல்லு.
R1
டேய்
சொல்லுடா.
இல்லவா ராஜேஷ் இருக்கியா?
இல்ல அவன் வாயை திறக்கூடாதுன்னு சொல்லிட்டு அந்நிய நாட்டு சதி மைக் பண்றாங்க, மியூட் பண்றாங்க.
ஷோம்குமார் சிங்
ஏய் எங்கடா ரஞ்சித் ஆளகணும்?
அவன் இன்னைக்கு காலைல வேலை இருக்குடா. அவன் நேத்து நைட்டு ரொம்ப லேட்டா பண்டில் போட போயிருந்தான்.
Guys, hold on.
Yes sir.
So what is the value? Our equivalent value?
2.5 I think so.
2.5.
1.42.
1.42. 1.42. After that what? Hello. Is it audible?
Yeah sir, you are audible only sir.
Yes, sir, audible, sir.
Yeah, 1.42 is okay. After that, no. I'm not asking about the remaining integers which is available. Can you please see the screen, guys?
Yes, sir.
Yes, sir.
So
No, sir.
1.42 kilo ohm, right?
எப்படி சார்?
Yes, sir.
Is it right?
Yes, sir.
Just simplify.
10
What is the value?
by 7.
Yeah. Wait, this is 5 plus this is 2k. Just remember. So if you take a common, I will re-change the equation as R equivalent is equal to R1 into R2 divided by R1 plus R2. Right? That is a formula, right? If I rewrite the equation. And R1 and R2 multiplication. So the 5k and 2k, if you multiply, you may get 10 what?
7.
10 plus 1.
10 divided by
R1 is
7.
5k.
10 by 7 sir.
10 by
R1
7.
is 5k. Listen, R1 is 5 kilo ohm and R2 is
10
5 kilo ohm.
Okay sir, just 10 sir. அதுக்கு மேல என்ன வரும்? 10 by 7 only.
7 sir.
10 by 7.
10 by 7.
10 to the
Sir,
power of
10 by 7, sir.
10 by 7 is
what is
equal
that
to
5k?
1.4.
Wait, 5k is nothing but 5,000, right?
Yeah sir.
If you multiplying 5k with 2k, what will be your answer? 10k into 10 to the power
10k.
of
7k.
K square, sir.
5,000. If you multiply with 2,000, what will be your answer? Whether it is 10,000 or
Sir, 10 into 10 ka power 6, sir.
6
So
Yes, sir.
divided by, here you are doing addition
Loaded.
only. So 5,000,
now 7.
2,000 is nothing but 7,000,
7 kills.
right? So otherwise I can write it as 7k. Okay, here I am having 10 to the power of 3. In numerator I am having 10 to
உங்க
the power of
கர்சர் திரும்பி
6.
ஒரே இடத்துல நின்னுங்க சார்.
Again,
Yes,
sir.
sir, not possible, sir.
நீங்க எழுதுறதே தெரியும் sir.
Okay, better take, all of you take a note. Take
Yes,
a
sir.
note.
Okay.
Yeah. So in the numerator,
Numerator will be 10.6 sir. 10 power 6 sir.
in
In power
is
6.
nothing but 10 into 10 to the power of 6. In denominator, it will be like 7 into 10 to the power of 3. So this 6 will be cancelled by 3, means you may get 3 only, right?
Yes,
If
sir.
it is power, you have to subtract the power. 6 minus 3 is nothing but 3. And 10 divided by 7 value is 1.2. So 1.42 K. Okay. Now you can apply the Ohm's law. V is equal to IR. So I know what is the V. V I given as 5, and the resistance is 1. Guys, mute your mic. One of your students. So V is equal to 5, and I found what is the equivalent resistance for that circuit. That is nothing but 1.42. Okay. So what will be your I? So last time you calculated individually. Now I calculated for entire circuit, so that I can able to calculate the T. So just try to calculate whether you are getting 3.5 milliamps. Just try to calculate it. Guys, calculate.
Yes, sir. So now
Yes, sir.
we have to calculate what's the I or V, sir. Is it calculation?
V is given 5 volt, and we
Yeah,
found
sir.
R equivalent for that circuit is 1.4
That
K.
is 5 by
Calculate I.
1.42 தானே sir?
Oh yeah, 5 by 1.42 K. What is your answer?
யாராவது calculator போட்டு சொல்லுங்க.
Sir, 3.52, sir.
Yeah, 5.2. If you
Yes.
use the 5 divided by 1.428, you may get 3.5 exactly. Okay.
Yes, sir.
If you
That is
divide,
3.52 milliamps, sir.
yeah, 3.5 milliamps you may get. So that is an
Sir,
answer.
milliamp எப்படி
So
sir போடுறது?
previously in,
சின்னதா M ன்னு போடணுமா sir? milliamp represent பண்ண.
yeah, M,
A. Okay, sir.
yeah. So can you able to see the screen, guys?
இல்ல sir.
No, sir.
Still, wait a second. I will share it again.
Take your time, sir. அப்புறம்டா ராஜேஷ் ஆன்சர் ஏதோ கண்டே பிடிச்சா பிடிச்சிட்டு இருக்கீங்க. சபரிநாதன் டிராவல் பண்ணிட்டு இருக்கேன் சொல்லுறேன். விஸ்வா ஒரு சின்ன திருத்தம்டா. நான் நம்ம காலேஜ் ஹாஸ்டல் மானத்தை ஏத்தவங்க கிட்ட போட்டோ கேட்கலடா, மானத்தை இறக்க போட்டோ கேட்கறேன். எனக்கு கொஞ்சம் அசிங்கமா இருக்கிற மாதிரி போட்டோ விட நான் இப்பன்னு பார்த்து கிளீனா இருக்கிற மாதிரி போட்டோ வச்சிருக்கேன்.
ஓகே, அடுத்த தடவை மாத்தி அனுப்ப சொல்றேன்.
அசிங்கமா இருக்கிற மாதிரி எனக்கு இப்பதான் டேமேஜ் பண்ணு.
சரி, நாளைக்கு காலைல அனுப்பி விடுறோம் எல்லாத்தையும் பேலன்ஸ் எல்லாம்.
பரவாயில்ல பொறுமையா அனுப்பு.
இப்ப எப்படி இருக்குன்னா நாளைக்கு காலைல போட்டோ வரும்.
இங்க எங்கெல்லாம் குப்பை இருக்கோ அந்த இடத்துல ஜூம் பண்ணி எடுத்து.
சரி
தல
Now slide is visible, sir. Series parallel connection. Which? காலங்காத்தால எழுந்துச்சு ரிட்டர்ன் தூங்க சுகமே பண்றேன்.
Sir, we can't hear you, sir.
தம்பி அதுக்கு அவர் ஏதாவது பேசணும். சார் can't hear us any
Sir?
noise, sir. Pin drop silent, sir.
Sir, are you there, sir?
சிவமே
Bro.
என்ன பண்ற?
No, bro. If someone calls you now, you should say "solra" like that, bro.
Hello?
Say "solra."
Is it audible? Yeah,
Sundra.
guys.
Yes, sir. Yes, sir. Now
Yes,
you're
sir.
audible.
Yes, sir.
Before
Sir,
that,
audible,
25
sir.
years single noise also.
Starting everything
Yes.
is gone fine. Now it's facing a lot of issues. Okay, have you got any images which I posted in chat box?
Yes, sir.
Yes,
Got
sir.
it, sir.
So this
Yes,
is the
sir.
this is the task I'm going to give to you. So here there is a series and parallel combination circuit, and the voltage is 8 volt, and R1 is 5k, R2 is 8k, R3 is 2k. Find out what is the voltage and what is the current. So current in the sense across the entire circuit, I mean total current, and calculate what is the individual voltage R1 and R2 and R3. Okay. So tomorrow you have
Sir,
to
எது சார் இன்னொரு
share
சொல்லுங்க சார். voltage across the circuit கண்டுபிடிக்கணும். அதுக்கப்புறம் வந்து
voltage.
வேற என்ன
No. Voltage across R1 and voltage across R2, voltage across R3. That you have to find. And the current, total current, and current through R2 and current through R3. Okay.
total current.
Sir, okay, sir. First சொன்னீங்களே V is equal to 5, I is equal to 3.5 milliampere வரணும்னு அதுக்கு ஆன்சர் சொல்லுங்க சார்.
I can get you. V is equal to
V இது previous sum சார். V is
Yes, sir.
equal to 5, I is equal to 3.5
அதுக்கு
milliampere.
ஆன்சர் வந்து 3.52 டா.
3.5 milliamps. We found.
That is answer.
Yeah, we found the answer.
R is equal to sir அப்ப
R I
R is equal
given
to
right.
1.42. 1.42 K.
ஓகேங்க சார்.
Okay. I think you slept in between the class or what? Huh? Okay, it's time for the attendance.
Yes, sir.
Everyone unmute and respond fastly. So I will complete it very fast. Homer, Mukhtar,
உள்ளேனையா.
guys, talk in English. Who is
Okay.
giving a voice to Homer?
Sir,
Shivam is
it's me,
giving.
sir. Umare, sir. Yes,
Yeah.
sir.
Okay.
Present, sir.
It's Homer or Homer?
Sir, it is Omar.
Homer. Okay.
You can call, sir, your wish. Omar or Omar.
Okay, Pradeep. Pradeep. Capson. Pragdishwar. Pragdishwaran.
Yes, sir.
Yeah. Prasant. Sorry, Prasad.
Present, sir.
Rafil.
Present, sir.
Rajasurya.
Present, sir.
Rakesh.
Present, sir.
Okay, Ranjit is absent. Ratesh.
Sir, Ranjit present, sir.
Ranjit 60.
Yes, sir. 60 Ranjit.
Is he available? Ranjit. Fine, and Rakesh is there.
Even Pradeep sir, Pradeep is also present sir. He's raising his hand sir. Chat box la பாருங்க sir, கை present போட்டுருக்கோம்.
Yeah. Ranjit,
பேச முடியல.
what Ranjit?
அவனும்
Okay,
பேசலாம்
what
sir, இப்பதான்
about
சொன்னா.
Ranjit?
டேய் ரஞ்சித் பேசுறா.
Just raise your
Sir,
hands, I
இப்பதான்
will
sir
see your
பேசணும்.
name. Raise your hands, Ranjit. Pradeep, okay.
Ranjit.
Ranjit. And his
Signal
name.
fault போல sir. He was talking now sir.
Because it's not showing in Camo. Camo automatically register if you come in, and we will verify.
Okay
Sir,
sir.
sometimes it's not possible, sir.
see sir, நார்த் இந்தியாவே சொல்லுது சார். சம்டைம்ஸ் சிக்னல் இஷ்யூ வருது
Wait,
சார். இருக்கிறவனுக்கு இல்லன்னு தான் காமிக்குது சார். ரியலி சீரியஸ்.
wait. Let me check.
So you can only tell the
I'll see
absent
when Ranjit.
roll number, sir.
That is. I can't find Ranjit name when he joined. Yes. Ranjit is not available and he is not joined me. Is it clear, guys? Can you hear me? Guys?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir, yes,
Ranjit
sir.
is not available, so I will make it absent. And Pradeep is okay. Pradeep is available. And he will join. And Ratesh is present.
Sir, number?
61. Ratesh.
Present, sir.
Present. And Ritishwaran is absent. Roshan. Sorry. Yeah, Roshan. Yeah, Roshan Ajim. Is he available? Absent. Sabrinathan.
No sir. Sir, Sabrinathan
Absent.
is signal issue sir. Sabrinath present sir. Signal issue.
Sir,
Roshan
present,
is
sir.
absent. Yeah. Okay, ma'am. Sajid. Sasi Rani is not
Absent,
available.
sir. Absent, sir.
Shaktivel.
Present, sir.
Shaktivel Armugam. Sanjay.
Sir, present, sir.
Okay,
Present,
Sarvesh.
sir.
Service
Present,
present,
sir.
sir. Service present, sir.
Okay, noted.
Satish Kumar, present, sir.
Satyamurthy.
Present, sir.
Sriram.
present, sir.
Sriram is absent.
No sir, he's in
And
class
Sheikh.
also, but you're not asking.
And Srikanth.
Present, sir.
Srikanth J and K both present. J and
Present,
K.
sir. Both present,
Okay.
sir.
Srinath P. Srinath.
Present, sir.
Srinivasan. Sorry.
Sir.
Srivashan.
Present, sir. Present, sir.
Suresh Balaji.
Present, sir.
Balaji. Santosh.
Present, sir.
Santosh present.
Present, sir.
Okay. Tikendra.
Present, sir.
Ahmed,
Present, sir.
Tejeshwaran,
Sir.
Tilagan,
Present, sir.
Tony,
Present, sir.
Vimal,
Present, sir.
Vishwa Balan,
Present, sir.
Shivam Kumar,
Present, sir.
Benjamin,
Present, sir.
Arnachalam,
Present, sir.
Okay, Rajesh Kumar,
Present, sir.
and Ronit Arora.
Yeah, present, sir.
Yeah. So tomorrow, everyone solve the problem and take a snapshot and post it in the chat box. Okay, I will verify.
Okay, sir.
Then I will provide that answer.
Sir,
Just
answer
as
is
of
1.43, sir.
டேய் உன்னை யாரா கேட்டாங்களா?
okay.
Sir?
Who is this Sanjay?
சிவம் ப்ரோ,
Resistance.
கண்ட்ரோல் ப்ரோ. அட்டெண்டன்ஸ் போடுற கேப்ல
Then
போய்
okay.
கண்ட்ரோல்.
If you are that much fast, then I will give more a problem. Okay.
சார்
Next
Sir, no,
class.
sir,
on
no,
that.
sir.
அந்த பையனை கிளாஸ்
Okay,
விட்டு தூக்குறீங்க சார்.
Okay, wait. I will post the attendance once.
சார் ஆக்சுவலி ரஞ்சித் குமார் கே பிரசன்ட் சார். he was talking சார். நானே கேட்டேன் சார்.
Is not available in call.
நம்பர் 62 கூட ஏதோ சொன்னா சார். ரோல் நம்பர் கூட சொன்னா சார். 16 நினைக்கிறேன்.
He is not available in the call, right? Just check it out. Check the
Okay, sir,
participant
yes, sir.
list. And it's not
Okay, sir. But
available.
I saw sir he was talking. That's why I'm saying.
Okay. Okay. Wait a second. I will post attendance.
Yes, sir.
Sir, Ranjit is present, sir. Texting me, sir.
Yes, sir. Adan sir. Present sir. We saw that he was talking sir. Saying roll number also 60, number 60 like that.
Signal problem.
Why can't he give any message to me or in chat box?
அதான் சார் அவனால எதுவுமே பண்ண முடியலையா. மைக் கூட மியூட்ல இருக்கான். ஸ்கிரீன்ஷாட் அனுப்பிச்சிருக்கேன் குரூப்ல. அப்படியே இருங்க. குரூப்ல நான் போஸ்ட் பண்றேன்.
Okay, post it.
1 minute sir. சரி விடுங்க சார். ஒரு அட்டெண்டன்ஸ்க்காக எஸ் சார் நம்ம இவ்வளவு கஷ்டப்படும். நீங்க போய் வேலைய பாருங்க.
Okay. Okay, thank you all. Thank you all.
Thank you sir. Thank you.
Thank you, sir.
Yeah, thank you.
Thank you, sir.
அடா சஞ்சய் எல்லாரும் போயிட்டு அப்புறம் கை தூக்குறா. என்ன பண்றேன்?
டேய் நான் எனக்கு சொல்லலடா, என் பேரு ரஞ்சித்னு மாத்த சொன்னேன்.
So this kind of activities you people are doing, renaming your name, guys.
Yes, sir.
Yeah, you people are changing the name.
Changing the name ah? ஐயோ.
Someone told that I will change the name likewise.
Who sir?
சொன்ன பேரை மாத்த சொன்னேன்ட்டு.
All are genuine sir here, no? Nothing like that sir. Sir, அடுத்த கிளாஸ் டைம் ஆச்சு சார். நாங்க போட்டா சார்.
Okay, yeah, you can leave. I already told you. People are available here.
Thank you, sir.
Yeah, thank you all. Bye.
Bye, sir.